So I do two things at Intel. I lead the cloud software strategy for the company, which turns out to mean there are customer value props that need to be addressed in the customer market. We talk to customers and other sources and identify those, and then we match those to unique Intel capabilities, and then work the ecosystem in between to go solve them. And this is a very strange problem for Intel, because Intel typically solves speeds and feeds problems, low-level stuff, and then we go work with the hypervisor or the OS guys, and we're done, right? So I'm an oddball in a hardware company because I try to go connect a lot of dots together. So there's a bunch of hardware guys who scratch their head and can't figure out why I exist. And just a room full of software people, so you get a kick. I had a meeting about 3 months ago for the group of people planning the 2017 processor. So welcome to life in a hardware company. And they want me to tell them what the cloud's going to require of that processor. Right? Now that's an interest. You know, in the software world, if you could build a 12-month roadmap, you've done pretty well. You know, these guys are building 5- and 7-year plans. John lives it with me. It's quite an interesting challenge in life. The other part of my day job is I run the Cloud Builders program, where we define reference architectures, and you'll actually see one of those come up. But a big part of being able to communicate these kinds of solutions is to be able to show a reference architecture. And we'll talk a bit more about that. The Intel motivation for this is the growth of connectivity, and there's a couple of trends that we see. It's the number of devices, it's the richness of content, and I'll call it the bring your own device mentality. Right? And for those of us who live in a corporate world, Intel is one of the more proactive companies that lets me take my non-Intel based phone, shame on me perhaps, but my non-Intel based phone, and go connect it to the internal Intel network, and it's treated like any other device. Now that's interesting, but there's a really painful side effect that most IT shops figure out as soon as they do that, is that I have the same expectation for rich services now across all my devices that I have when I use this in a consumer mode. And so between more devices, richer content, and now richer sets of ways to access that content, it's what drives the mentality. And of course we like to quote the numbers on numbers of devices and terabytes moved and exabytes moved and all that other, but fundamentally that's what's driving the change. I thought this would be kind of interesting given where you're focusing on, and a bunch of the discussion we just had over the last hour and a half. The Open Data Center Alliance is a group of end users who there's more than 300 IT companies represent more than $100 billion worth of IT spend, and they get together and they write down usage models, and I think I'll show you some of them here in a minute. Well, and they're writing them down in a form that are fairly specific. So they may say things like carbon footprint reporting, but then they'll define what that means, and what that means from terms of reporting. And so for those of us who are trying to connect the dots between low-level speeds and feeds and end-user pain points, this is actually a pretty powerful statement. And so we asked them, or they asked themselves, probably more accurately, what are the pain points that they see? Know how in all of the normal surveys security is at the top of the list? Well, security is actually numbers 2, 3, and 4 here, or 2 and 3, right? Number 1 is migrating apps into the cloud, which was the genesis of one of my early questions. So I got a bunch of legacy garbage. I may know how to build it. I probably do, but I might not. And now suddenly I want to have it hosted in a cloud environment where I have the ability to move it, at least monitor it, do a lot of other things. And this is the top pain point that they highlight now. And as I talk to IT groups, can they convert a machine to a VM? Of course they can. Dozens of tools out there to go do that. Can they upload it into Amazon and run it? Yeah, absolutely they can do that. There's tools to get you across that hurdle. Painful, but there's tools to do it. Can you run it in there? No. Turns out that sucks. Right? It's dependent upon all of these Active Directory services or LDAP services or all these data sources that have to be authenticated through tunnel. It turns out all that garbage means no, you can't do it. That's what number 1 is. Right? Numbers 2 and 3 are the traditional security ones, to be honest, and I was really happy that they were specific, maintaining security SLAs. That's okay, good, they're being specific finally, right? The new security requirements emerging. The hidden the thing that they didn't say behind this one is, and what I hear from CIOs is that the security we're requiring of cloud applications is actually higher than we require in our corporate IT. And when you dig under the covers, you find that this is the security level they actually thought they needed, but they could never figure out how to get in the traditional world, right? And so, on one hand, it's unfair. We got to go meet a higher bar. On the other hand, it's the bar we should have met 20 years ago anyway. So, it's about time, I guess, we got there. So I thought, given your focus, boy, are you dead in the spot, right? It turns out it didn't actually make it on this chart, but one of their ODCA is an independent company. It's not Intel, by the way. We're a technical advisor. I thought technical meant I'm an engineer, technical stuff. No, technical advisor means we call the meetings, keep the minutes, pay the lawyers, and all those kinds of things, right? It turns out one of their corporate go-dos is how to manage, how to implement interoperability across the industry. So the very focus of your work is actually the sweet spot of what they're trying to go achieve. So that's why it's not up here directly, because this is, if you will, in their eyes, implementing to that other goal. So just very briefly, as we look down the road, we think we have to have 3 attributes in clouds. I'm sure there's lots of others, but these are the 3 we'll choose to focus on. Federated, which is right in your wheelhouse. Federated meaning your data and compute are never in exactly one location. They're by definition spread across. And we're seeing maybe 10% of corporations today admit that they're doing this or understand it, but probably 50% of them actually are. So Intel employee expense reporting is actually a SaaS service. So by definition, we already have a couple of clouds. One of them just happens to be a SaaS service that gives us employee expense reporting, right? So most companies may not associate that as a part of the federation that they already have to do. And federation, because I have to share identity and I have to share trust levels, there's all kinds of things that goes on there. The second one is automated, and automated here is not for the sake of sequencing things or doing that. That's a technology, and it doesn't directly translate to business value. Automation here is about consistency. It's about agility. And it's about the ability to create an environment that is aware of itself, right? And I don't want to don't play too much into that. I'm not being sci-fi here, but introspection is an important part of capability, and automation here is trying to embrace that. Meaning, as I deploy things, I can be aware of what I have and what I don't have in capabilities.
Self-monitoring.
Yeah, self-monitoring. Yeah, probably a better way to describe it.
Which is Commons' role, is self-monitoring too.
Yeah, but better said probably. So client aware is probably the one that's bizarre here, and it was thoughtfully placed. And the idea is that as I have a device, I don't want to see 1020 HD show up on my iPhone because it can't display it, and I don't want to pay for the bandwidth if it could. On the other hand, if I'm at home watching it on full screen TV, I don't want whatever resolution here is to show up on my home TV. And as I interact with it, the response time, the quality of service attributes, the video needs to follow that pattern, and if I need to transfer the experience from here to my laptop, I'd like for that to work. And what we're finding is that this is a necessary element. It's not clear how to go implement it. Right? So this is one of those vision statements.
That's actually one of the components of the cloud pod architecture, what we call the terminal management framework, providing the means to the client to get to that which is deployed.
Yeah, and there's a bunch of holes there, right? And
yes.
Android's not helping us in it.
No, not at all.
So devil in the details on that one.
Yeah.
And so these are the 3 areas that we're choosing to focus on. We've evolved this, if you will, by looking at it in terms of phases. I think you're ahead of the curve in terms of what you're implementing, but given the purpose of the program, that's where you should be, right? Matter of fact, if you weren't, I think that'd be a red flag, right? But the fact that you're already trying to build the predictive, these other services is a big deal. We showed this to a number of customers in the U.S., some analysts, and I was in Taiwan Monday and Tuesday of this week, and we showed it to some customers there, and almost every one of them said, we like the phasing and agree, except the dates are wrong. It doesn't happen this fast. So I think we're on the right trail, but it's gonna, and I think we're going to have a Gaussian distribution, and there's going to be laggards and leaders, right? Intel ITs, it turns out, in the leader bucket, and to them this is like old news, right? Most of the industry, the 3 Sigma part in the middle, is saying that these dates are too aggressive still. So we'll see how that plays out. Intel as an organization chooses to focus on a pretty wide orders of magnitude of stuff. So I was at HP before Intel, and I thought HP had a pretty wide dynamic range of skills. You know, people run factories and supply chains and software and hardware. Well, I get to Intel and all that crap before you build a system. You know, chemists and physicists and holy crap. You know, there's a whole amazing array of stuff that goes on. And so that's kind of the levers that Intel has to play with. And so you find things like new Xeon systems that we've all learned on Moore's Law, you know, gives us an amazing train. We also play with the technologies how they get used. So do you know SR-IOV? For virtual machines, it's a way to take I/O and directly connect it to the guest. So rather than all the I/O have to go through the DOM0, the I/O can go directly to the guest. And clearly it's intended as a means to reduce the overhead in the overall virtualization environment. So I'm maybe an outlier, but I'm questioning why any workload 5 years out would ever want to be bare metal. Right. If I can get the overhead down to 1% or less, which is about where it is in that environment, why do you care at that point? And don't you want the portability and the manageability aspects, right? So there's a whole bunch of work going on here to look at data center level efficiencies. We have some things called Node Manager that lets us delegate power policies out to the node. So at the OpenStack level, as opposed to CompatibleOne directly, we can manage workloads in the context of power and thermal, and that's actually one of the areas we're contributing back into the OpenStack world. We also look at software, and software. Intel is in a unique role that we work with a lot of the very large, very large data center guys. So like Google, Yahoo, Amazon, eBay, those guys, Baidu, Tencent. There's bunches of them. And sometimes they come ask us to help them optimize their code. Okay, sometimes happens like multiple times a day, right? I mean, a lot, right? And last year we did a project with a large social networking site in the U.S. If you can't figure out who that is, come see me after the beer. They use Memcached. You guys know Memcached?
Yes.
They were able to get about 400,000 reads and writes mixed traffic per second on their current instances. With some work, we followed their rules of partitioning. So they had one in-memory partition instance per box. You can get better throughput if you do more partitions, but they have one per. So we stuck with their rule. We quit when we got to about 4 million reads per second. So Memcached been around a while. Not that long, but it's been around a while. It's already been optimized a few times. Well, it turns out there were locks all over the place that nobody knew about. Okay, I'm sure they knew, but nobody thought they were performance barriers. We quit at 4 million, by the way, because that particular company told us they could only consume about 3 million. And so they're probably now back in their shop trying to figure out how to use more, right? Because the next generation with Sandy Bridge and others gets us even more performance. So, but what happens when we do those optimizations is certainly they get a benefit, the open source community gets a benefit, but also we then go retrospect back into the platform and say, how should the memory be designed? How should non-volatile play into this design? How should what are the instructions used that would optimize these sequences? How does the power translate to a per transaction? It lets us go do some pretty interesting analysis, which really only Intel is in a position to go do. You know, we have our hardware guys like these things called traces. So software guys, we know what a trace is, right? I had no idea I thought I knew what a trace was. I turned out to be an idiot. Right? These traces are incredibly micro level interesting because they care about when the instruction pipeline stalls, because that's wasted power in their eyes. Performance wasted for sure, but also wasted power. And so they go to an incredibly fine level of detail when they capture these traces. And so it's hard to imagine as an industry to be able to go drive to that level of efficiency and performance that we all demand when we carry around Intel-based phones. You know, how do you get that efficiency unless you can go to that level of detail? So that's just one. So software. I'll show you an example of how we're working with the systems industry. We're also doing work at the data center level, which that probably feels like software. Why are you going that far? But it turns out if you want to build an efficient, thermally designed data center, you really, for the past 20 years, we've been doing it all assuming we could not change the compute servers and network elements in the data center. And we got pretty good, right? We got to about 35 kW rack. That's pretty good, actually. Right? it's hard to go much. You can get to 50 if you really know what the hell you're doing. And we had to learn how to do things like hot and cold aisle isolation. But if you want to go beyond that, it turns out you got to start back at the base platform. And so we, with Facebook and some others, started a project called the Open Compute Project. And this one's interesting because we, about 2.5 years ago, we designed a motherboard that had no thermal shadows. We were the first one in the industry to try to do that. And it was at the behest of a couple of very large providers in the U.S. Most motherboard designs, we're sitting around a bunch. If you have HP, Dell, IBM systems, they're designed around form factor, not around thermal efficiency. Right? And there's a reason, because we tended to pay for the form factor, not the efficiency. Well, if you're the Googles of the world, I got space. What I need is efficiency. Right? Power efficiency, power performance matters more. And so we designed a motherboard that had no thermal shadows. And the definition is no high dissipation parts could be downwind of another high dissipation part. And as soon as you did that, you get to make a choice. You can either reduce the fan speed or you can raise the temperature in the data center. Well, that begs the question, how far can I raise the temperature in the data center? Right? So we Intel IT, took part of our Exchange email system, put it into a set of racks in New Mexico. I don't know the European equivalent. It's hot and dry and dusty in New Mexico. I guess except in the dead of winter, which is damn cold and snowing. But they did this in the summer and ran the rack, and they wanted to find out what are the failures going to be. Where are we going to see issues? Yes, the disk drive failure rate went up marginally. No, the silicon components did not go up measurably. And I'm sure you've probably seen the Google article since then that talks about the fits on silicon not doubling with temperature change. I don't know if you haven't seen it. There's a Google paper where they did some critical analysis of silicon failure as a function of temperature. It was a U.S. military study, God, 30 years ago probably now, where they said that I guess for every 10 degrees C rise in temperature, the failure rate doubled. And it turns out that the failure rates we're seeing today are nowhere near that high. And so what we see when we run data centers as much as 40 degrees C now, besides being really uncomfortable to go into, there's no appreciable change in failure rates. Right? So this now enables Facebook to go build a data center in Prineville, Oregon that has no chillers. So it's a full out data center, you know, I don't know how many, it's more than 10 megawatt data center and no chillers.
So you have one data center in France built almost with no roof and
oh, yeah.
circulation like that. It's interesting to see that.
Yeah, it is.
It's an eco something.
And you know what they found out, I'm sure they did here too, is that you actually have to recirculate some percentage of the air to keep it warm enough at certain times of the year. So why were we running chillers? No, this is nuts. And in Prineville, Oregon, in the summer they have to put misters in the air because even though it's quite warm, it's too dry and it doesn't absorb the heat. Right? But there's no chillers, so the PUE rating on these things are incredible. So the Open Compute Project, and this is open source stuff, you guys can go look at it. This is open source hardware. Open source motherboards, chassis, racks, and data center designs. Facebook has published all of the specs on their systems, the misters, how they keep them from blocking up with calcium deposits. I mean, the whole thing. It's all out there if you want to go look at it. So we view this stuff as pretty fundamental because this turns out to enable the ODMs, which work upstream of the OEMs, and can feed a lot of the industry. This is interesting stuff. It's worth taking a look. James Hamilton, I guess he's at Amazon now, keeps a blog, and about a year ago wrote a very interesting, in-detail article on the Prineville data center of Facebook. They took him on a tour. So he's Amazon. I guess he's not competition, I suppose. He's just an industry sort. And he goes, and they let him take pictures and publish the details. So James Hamilton's Perspectives blog has some really good details. I'm going to skip that for here. So one of the things that I wanted to highlight as you were going through is we've done some work to try to identify who we think the actors are in this environment, and there's another layer behind this, but this is probably good enough. And I led the DMTF Cloud Incubator, which was the prelude to the DMTF Cloud Management Working Group. Mark Johnson has done a great job with it since I left. I'm glad for what he's done. We identified really there's three elements here. There's the consumers, providers, and then there's the person actually using the service that got created. We're going to ignore him for a minute because we love him, but he's not really relevant to our discussion. There's the people who actually define what's going to be done. So your work is largely centered, I want to say, on this side of the equation, right? I want to define the app and what are the characteristics and SLAs, and that's when I want to go drive into the system. But then there's the other part that talks about how do I make sure it got delivered, how do I create the services, all of that stuff. In this level of detail turned out to be important for us to understand how these things get rendered and what are the, I hate to call them UIs, but that mental model that makes it work here. What are the actions that a given actor is going to have to go do when you create these systems? And so, for example, the metering turns out to be a part of the capacity planning and related stuff. The services development means I'm going to choose to host some services. I'll show you my definition of the list of services in a minute. Operations, of course, has to actually make this stuff run on a day-to-day basis. And then there's those facility guys. Right? And one of the dirty secrets in our industry right now is that the facilities guys pay the power bill, and the IT guys don't. And so if you go tell them you know how to save 5% on power, tell the IT guy that, he says, don't care. I don't write the checks. It's invisible to him. It's not true for the very big, Facebook, Google, those guys, the same group pays the bill, so they care a lot about power, a lot. And they go to great lengths to minimize it. But most enterprise IT, these guys pay the bill, and the rest of the group just gets to live off the free power. I guess funny story there, Google has now 2 data centers outside of the Dales, Oregon. Turns out the Dales, Oregon has a giant dam where they generate hydro facility, generate power. Every year about now, the snow melts off the mountains, the Cascade Mountains, and runs down the Colorado River. And they have to open up all the sluice gates and generate as much power as they can. So they have to tell the wind turbines to stop because they got too much power. Google sits right there with a direct feed off the dam. They'll take all the power they can get, so they get free power for a couple of months a year. So if you want to be a really big guy, you can get all the power you can burn a couple of months a year. It gives global load management a whole new meaning, doesn't it? So what I was looking for as you were going through was largely, I hate to say graphics in this picture, but I've got a lonely DevOps guy building an app that's going to have to be fed through a couple of providers. How does that work? And you see our cloud machine concept, but we don't care if it's physical or virtual. And I like your point that it could be a PaaS instance as well, manifest for a PaaS, right? And so for purposes you're going to see from here in the next couple of slides, we call this CrossCloud Management. And forget the machine, but CrossCloud Management. So I got nervous on the term broker or whatever the other hybrid clouds. I couldn't figure out how to use those with any specificity. So we gave up and created our own term, call it CrossCloud. I'm happy to use an industry term when it emerges. I just couldn't figure one out. So shoot me, I'm the guy who made up the term. What we were looking for was the concept of how does that need to work, right? And I think you've done a lot of refinement to practice on how that actually needs to come into place. But again, we're looking at this from the context of those actors. How do they interact with the system? So we see 2 primary usage models in this environment. One has to do with, I'll call it migration. Remember, my definition of migration might not be a V motion. It might be a start new, shoot old. But the migration has to be something that can comprehend it. And so to some degree, that's change management within a defined service. Right? The second one is the ability to bring a workload in. The first of the ODCA priorities. Have a traditional legacy workload. How the hell do I bring it in? And Citrix has a product line focused on this, right? So it tells you that it's existing in the world. And then the true definition of brokering that you were using, where there's a set of decisions being made based upon policies as to how I manage the workloads, right?
Basically, we use the term broker because
that's what NIST uses.
Yes.
Yeah, no, I noticed. Yeah, I thought that was. I tried to do the same thing here, right? Yeah, exactly. So those are the 3 areas we see focus. So the next question one might ask is, okay, if we go down this path, which workloads are going to show up there, or where are they going to show up? And this came from AlphaWise SM, I don't know who they are, part of Morgan Stanley apparently. And this shows that within 3 years, we should expect to see about 30%, 36% of workloads being hybrid, meaning running in multiple environments. What is interesting about this survey, which, by the way, puts a little yellow flag for me, is they included PaaS and SaaS in the service. You know, so it makes me kind of wonder: did the people answering the question actually know what they were answering? You know, hate to be critical of surveys because they're always God's answer, right? But makes me kind of suspicious about the results. But anyway, what this tells us, though, and we've talked to enough enterprise IT shops. This is credible, even though I may question some of the results. When we talk to our own enterprise board of advisors, they're telling us that 20 to 40% of their workloads will be split by design across multiple clouds. When you dig into the why, some of it is feature. Terramark hosts services that are targeted towards enterprise and government. They'll choose those because of that. Some of them they will choose like Amazon because it's cheap, available, whatever, right? And then security, not an issue. So we're going to find this kind of mix going on. We also see an enormous trend for PaaS. I don't know if you guys follow the PaaS world, but with the advent of Cloud Foundry, Iron Foundry, Heroku getting bought, we think there's a knee in the curve within the next 2 years on terms of PaaS usage. And especially any of us who've actually had to build a VM and run it and then go, oh crap, that wasn't exactly what I wanted. You get really motivated to go use a PaaS pretty quick. And so I think those of us doing IaaS need to get this thing nailed pretty quick and be ready for the next wave.
Yeah. Provide to their needs.
I'm sorry?
To provide to their needs.
Yeah, exactly. Be the reliable underpinning for their needs.
Exactly.
Absolutely agree.
That's what it's about.
So in the context of trying to figure out what would be below, I'll call it below the API line, and trying to say what's relevant for us to go build. I did a bunch of digging on service providers to say what are the services they actually run, and trying to answer the question, shall we say, what's in scope, and not trying to exclude things, but trying to actually be more embracive than not. And the genesis for this was an Intel IT internal cloud that they built, and I'll actually show you a slight more detail on the internal IT cloud. But there's a chunk of IT ops, and these are things you probably already know about, workload management, performance management, asset, security and event management, config management, capacity, monitoring. There's a whole bunch of those things that they have to do on a day-to-day basis. And in one way or the other, we have to tell them how to go do those. Like let me say it another way around. If we build a cloud solution that doesn't answer those, then they're going to have to go make up their own answer. And that's sometimes helpful, but the bag of parts model that those of us vendors have been putting on on our customers for the last 20 years is probably not a sustainable model. We've got to be. It doesn't mean we have to go vertical on the solution and say thou shalt use Nagios for infrastructure monitoring. We have to say Nagios is one example of how to go do it. There may be others. Here's how to use Nagios to go do that. Right? So it's an open definition, but we got to say here's an example of how to go do it. And then the traditional cloud management, which is what OpenStack would do, is this blue blob on the left, and we expect that those have to mature as well. And there's a fairly, I know this is block diagram level stuff, but there's a lot of assumptions in there around policies and how those work that are frankly not implemented today, right? OpenStack has pretty weak scheduler policy primitives. That's changing with Folsom, or getting better with Folsom, but still be fairly weak. They've been pretty good on virtualization management. They're getting better on identity or linking to identity management systems. Still got a ways to go there. And then last and certainly not least, on the right-hand side is actually probably the biggest box. So if you were to show it in the size of the lines of code or in revenue, those others shrink down to a dot, and this one blows up, right? So when you go use Amazon, you expect to find databases and object stores, message queues. You expect durability of services, all those things to be there. And so one could argue, and I really hesitated when I drew this, to put those on top of this other stuff, right? And that may be the right way it actually gets implemented. But from the user of a cloud, these are just additional services. And so our own Intel IT guys are telling me that the fact that we now have an open source based private cloud is great. It's actually allowed us to go do new things. But until we can start hosting a rich collection of these, that's the barrier to broader use of our own internal cloud, right? Which is kind of a good news, bad news. You know, great, we got a private cloud working. Oh crap, I still can't use it. Right? It's one of those scenarios. So I've taken the position for Intel that says we have to get this entire portfolio enabled in the ecosystem, and if it doesn't care about Intel stuff, that's okay. And I'm happy if a partner goes and nails it. That's great. I don't. You know, this one doesn't. Well, it does. The very top one, Hadoop. I'm not going to go Hadoop or do anything on Hadoop right now, but I have to make certain it exists and can run well in this environment, bare metal or hosted. I don't really care, right? And so this is from a day job standpoint. This is the kind of scope. But given that you saw Intel focusing on what we call gates to grid. This is the gates to grid equivalent in the software side. Now, I will say, as we did the analysis of our own work, it's pretty hard to find something up there that doesn't care about the silicon. You'd like to argue everything's abstracted out, but it turns out at the end of the day, you really do need to know something. You can do a better job on config management or capacity management if you know the underlying hardware information.
Hardware is still mandatory.
I'm sorry?
Hardware is still mandatory.
You still gotta have the damn hardware. Yeah, exactly.
Everywhere nothing works.
Yeah, for example, capacity management, everybody said, nah, it doesn't matter. Well, it turns out if you say that VM is running at 100% utilization, well, I need to know what is it running on and in, and how much memory, and a lot of attributes matter there. So this is, I think we're going to see a lot of maturity there as we go forward. So one more, and then I'll show you the Intel IT picture. So knowing what we're going to talk about today, I stole this out of one of my colleagues' decks. He's working on cross-cloud related stuff, and he gathered this from about 30 meetings with customers and trying to figure out what, and I asked a couple of questions to clarify here, so as we were going through. So I think you got most of these checked off, to be honest. Which I thought was pretty interesting, because you hadn't seen this before I got here.
No, but can we keep it?
Yeah, you can absolutely have a copy of this. Yeah. Probably the one that I tried to figure out if I should ask a question. It uses existing IT people. Probably not your problem, right? But that's the reality check, at least. Well, so the IT challenge is, I don't know the numbers at Intel. We have a bunch of people who are storage specialists, and they don't get to go away. I still have to have data management policies and backup and retention and destruction. I still have to do all of that stuff, right? The fact that in cloud a lot of that's automated makes the people then jump to and say, well, I don't need those people. No, I still need them, but I need them to do a different thing, right? And so the point from our customers on that bullet was, I have storage guys, they're now, instead of managing a SAN, they're going to be managing a distributed replicated storage.
Even designing it.
Yeah, designing it. Yeah, exactly. Yeah, do I use Gluster or do I use, and what does it mean for replication? And what about dedupe in this environment across the street? It gets a lot more complicated, so we still need those guys. So the customers tell us that bullet's actually pretty important, but I'm not sure how. And you know what our own IT proof is? That has never happened. The fact that we have an internal cloud has not caused anybody to go home. Right?
Yes. What I'm saying about cloud is the first time in the IT history that we apply to ourselves what we used to apply to enterprise.
Yeah. So there's an interesting dynamic here that we face internally at Intel, which is, so let's talk about when virtualization was introduced. And the big fear of those is in the infrastructure side was virtualization is going to mean the world will buy less servers, right? Because if it's virtualized, I can take 20 to 1, I won't need 19 servers, right? Well, what has happened instead? Well, I filled up that server and I bought 19 more that I filled up running even more stuff, right? So my inference out of that is there's an elasticity of demand here. So as we've lowered the price to deploy, manage, and operate an app through its life cycle down to really small numbers, that proves there's elasticity on demand. And as we did some modeling to say, let's take that cost down even further, there's still even more elasticity of demand. So I'm one of those that believes if we can start knocking some of these down in a credible way, a way that IT trusts them, we'll actually grow the size of the server business in general in the planet. Right? That's kind of an interesting problem to solve.
Yeah.
Okay, last. Well, actually, next to last.
Big data, small fun.
Yeah, big data is going to be the next major
Small
camera.
funds.
Yeah. So Intel IT has deployed an open source based private cloud. It's in production today at Intel. It's based upon OpenStack and Nagios and Puppet and some other stuff. So some of those.
You didn't jump to SX.
No. Well, so there's a whole different story with ESX. We actually have an a VMware based cloud internally, and we had to do that because we have a lot of VMware based workloads today. And so we put a front end on them and all that stuff. Life's great, right? But if you look at the cost and innovation curves, they're actually in the open source world. And so those two vectors drove us to go build an open source cloud. Some of you may have noticed the Intel DMZ. That's actually where it's implemented. So they didn't start with the easy part, they started with the hardest part of the solution. And that's where they've implemented today. And so this is in place. We actually have one production application that's a world-facing app today that's running in this cloud. It's a multi-data center. So if you happen to use the product AppUp, which is an Intel store for netbooks, now moving to ultrabooks and other devices, the data store that's behind those, not the BSS, but the data store that's behind those is actually in this cloud running today. So I think it's a testament to it's possible, it can be done. Intel has some amazingly bright IT architects that work. It took about 18 months to go from, hey, let's go build one, to we know how to pass all the security tests, the audits, and all that. It took about 18 months. And this is the third implementation of the open source one. They've abandoned two others before this. Not that abandoning is good or bad, but that's just part of the learning curve to get to this point. There will be an Intel IT white paper that goes into some more detail on this. I'm surprised we're not done yet. I keep giving them hell because we're not done. Questions on this?
OpenStack Diablo Plus?
I'm sorry?
The OpenStack Diablo Plus?
Yeah, so they took Diablo and enhanced the hell out of it.
Okay, yeah, but they didn't really kind of
Yeah.
Is it beyond Essex or before Essex?
So this was before Essex. So they went in
Yeah.
production in March, so they had to lock it down before Essex. Almost all of the changes have been turned back into the community. The ones that weren't was because the community was rewriting those modules that it didn't make sense to turn them in.
Right.
So they've turned almost all of that back in at this point. Their expectation, by the way, is to not deploy Essex, but to deploy Folsom.
Yeah.
And it's not a matter of they don't like Essex. It was they can only really afford to do a couple of upgrades a year.
You encounter message format difference between Diablo and Essex.
Yeah.
I hope you don't change again for Folsom.
Yeah, we ought to give that to the community.
Yeah.
One last topic. So one of the things I think we'd like to work with you on is to implement trusted pools in support of audit models, and I'd like to do it through metadata specs, perhaps SLA. I'm open to how we go do it.
Yeah.
Matter of fact, I'd like your guidance on how to go do it. Let me be honest. Trusted pools is something that OpenStack would implement and then would expose as a capability. I'm not sure. I won't even try to get into your words, right? But that's how I view this. We are working across the industry to drive some software stacks to support it. So, for example, in a VMware environment, we'll use HITRUST and/or RSA Archer to implement the policy management and the GRC functions that go with it. Now, so we've implemented one of the key things that has to happen. Oh, that's good. There's the text. One of the key things you have to do actually, I think I actually want the next slide. Nope, stay here, sorry. One of the things that you need to do trust is you need to have an ability to pull from the device an indication of its trust status. And so the first part is a trusted boot, trusted launch, trusted boot. So you boot the system and you want some metrics generated at boot time that you can later pull to say, I know the provenance of the system that got loaded. Second part is I want to establish policies that establish the pools. So these pools can only contain servers with a known trust. These servers may have a different known trust. They're different somehow. And then the last is to provide support for the compliance and audit, right? And so we implemented a project called Open Attestation. It's an open source project under Apache license that knows how to pull, uses a host agent to pull the hardware-based signatures from the server, bring them into a service, an attestation service, and then the attestation service has a whitelist. You have to externally give it the whitelist. It can't figure this out on its own. You don't want it to figure it out on its own. And then you can externally query it and say, is the server behind this IP address? Give me his trust status. Pardon?
Yeah, that's correct.
So this is in open source. It's released open source. I don't know which cycle they're in. I can't speak to that stuff. But this is how you can use the hardware-based root of trust in a system today. So just a little bit more on the hardware root of trust. The way this is implemented is there's a module on the hardware called a TPM. You guys know TPMs? So TPM is a magic piece of silicon that you write values to in the clear, but you only get them back encrypted. And so when we boot a server, before we run a module, we create a SHA-1 hash, take that hash and shove it in the TPM. And of course, I guess you write it in the clear, but who cares at that point, right? And then I come back later, after the system's booted, I've run a whole bunch of modules. Now I have, I think it's about a dozen signatures that I've kept in the TPM. I come along later and I pull those out. And when I pull them out, I now know two things. I know that it in fact came from a server that's mine, because I had to use one of my certificates to decode it. So I now know it's mine. And I now know the signatures, which I can then use against my whitelist to say, yes, this server is allowed to be run in a PCI compliant pool. Right? It turns out there's a third thing that if you provision the hardware with a value and a register that, let's say you choose the values to represent your data center locations, then you now know where it is too physically. Right? So it doesn't discover its own location, but if you install it and say, okay, this is data center 14, which I know is in Grenoble, right, so I get geolocation in a trusted form.
Yeah, that's what I was thinking. What about looking up geolocations of the actual chips, and then you can actually trust the geolocation.
This is the best way we found to do it.
So we'll have an API exposing all the hardware.
Yep.
It's perfect.
Yeah.
Perfect for the placement.
I'm sure there's glitches in here, but this is
This is a good blueprint to work from.
Yeah. So we'd like to work with with the community to implement the trust as it's needed by the customers, which is probably an SLA definition that then drives things like OpenStack and others to actually use the trusted pools.
Yes.
Right?
Yeah.
So I'm not sure where the gaps are to go do that. I'd love to have more of that.
We'll find out.